All right, so we had section 5.2 today, so now let's go ahead and work with some example problems with this. And this is just to see kind of where we're at. I suggest on this one is writing down the problem, trying it on your own while the video is paused, and then checking your work by pressing play. So just an FYI, see where you're at. Of course, if you want to follow along with me, that's up to you too. So starting with example 1, we have 2 to the power of 2 over 3 times 16 to the power of 2 over 3 all over 4 to the power of 2 over 3. It's a little exponent in there. It's hard to see. Okay, so when we're working with these, it's always kind of like a little bit of a puzzle. And you want to see, like, how can I approach this? What's the best way to go for it? I noticed that every single one of these exponents are exactly the same. So using our exponent rules, we can actually pull this exponent out to the side, right? Because we're kind of doing the reverse of applying that exponent rule. We're going to pull it out to the top, out of the parentheses, meaning that we can have 2 times 16 over 4. And now, those are all integers numbers that we can go ahead and reduce on this one. Well, we know that 4 and 16 are going to reduce. That leaves us with 2 times 4. So now, is that 2 times 4 to the power of 2/3. All right, now that's 8 to the power of 2/3. That's much easier to deal with. As a reminder, this is your cube root of 8. So we're going to take the cube root of 8. Cube root of 8 is 2. We're going to keep that to the power of 2. 2 to the power of 2 is 4. That's our final answer for that. All that work to get you down to one solid integer. How'd you do? Did you get it on your own? All right, example 2. And FYI, I think I have a total of like 8 example problems somewhere in there. Let's take a peek at something with some same bases. So 49 to the power of 3 over 8 times 49 to the power of 7 over 8 all over 7 to the power of 5 over 4. Okay, so as we start to look at these, you'll start to notice that some of them have same bases, and when you have same bases, it's a good idea to combine them. Some of them have the same exponents. It might be a good idea to kind of pull that exponent out. We know that the 49 and the 49, so this is same base, mean that we can go ahead, we can add those exponents up together. We're going to add 3 over 8 plus 7 over 8. That's going to get us to a 10 over 8, so 49, I'm going to go ahead and write that step there. So you see that we just added the exponents together, giving us 7 to the power of 5 over 4. Well, now we can reduce this fraction. We can reduce 10 over 8. So we can reduce that to 49 to the power of 5 over 4 over 7 to the power of 5 over 4. And now you notice that these have the same exponents. And if they have the same exponents, I'm going to go ahead, I'm going to pull those out to be one exponent on the outside of those parentheses, leaving us with 49 over 7. We need a little bit of help seeing that, just for an FYI here, is that if you were given this problem, so if you're given this problem right here, and the screen's moving, you would go ahead, you would apply your exponent here. So we kind of just did those exponent rules backwards. Exponent rules backwards on that one. All right, but what we love about that is that allows us to reduce that 49 over 7 to 7 to the power of 5 over 4. And that's our final answer there, because we cannot take the 4th root of 7. We're not going to apply it. We're not going to say 7 to the power of 5. That's going to give us a really big number on that one. So that's actually a final answer right there. I know it gets a little bit tricky saying, hey, can I do anything else on it? But just kind of run through all your options. You're down to one term. Looks pretty good. All right, example 3. We're looking at we're going to go to some roots here, radicals. So cube root of 16 times cube root of 32. All right, there's a few different ways that you could think about this. Number one, they are both cube roots, and you could go ahead and you could say, well, we can multiply those out together and they would get 512, and the cube root of 512 is 8. All right, well, maybe you're sitting in the classroom and you don't have a calculator in front of you and you want to walk this through. So let's look at option 2 on this one, just to show you there's another way to solve it. So I'm just going to rewrite it over here. To the 16th times cube root 32. All right, so first thing that I'm going to look at is that I know we can go ahead and break both of these down. So I'm going to say cube root of 16 can be broken down into 8 times 2 times the cube root of 8 times 4. And the reason that I'm breaking it down into these factors is because 8's a cube root, right? It's a perfect cube. When we break out that cube root, it's going to be 2 cube root 2 is what you're left over with, times 2 cube root 4. All right, now we're going to go ahead. I'm going to multiply the 2 times 2. That's going to get us 4. And I'm going to multiply our cube roots. So 2 times 4 is going to be 8. Hey, we know the cube root of 8. 4 times 2, that's going to get us to 8. So that was a long way of doing it, but that's probably how you would break it down if you didn't have a calculator in front of you, or if you didn't know the exact cube root of 512. Different options to get you to the same answer. Switch over to some pink. All right, we're going to stick with our radicals here for a second. Example 4, we're going to have the cube root of 3 times, this is going to be a fraction FYI, cube root of 18 over the 6th root of 2 times the 6th root of 2. All right, I did this 2 different ways on this one, and let's go ahead and let's kind of peek it out. Number one is whenever I'm not quite sure how to combine these or whatnot, I like to switch it over to exponents. So whenever I'm stuck, I'm going to switch to exponents on this one. First, I'm going to multiply these together. So 3 times 18, that's going to get me 54. So cube root of 54, and we know 2 times 2, so 6 root of 4. And at this point, I was a little bit stuck, so I'm like, hey, let's switch these to exponents and see what we can do. So 54 to the power of 1/3 over 4 to the power of 1/6. Still a little tricky on this one. So here, I'm going to actually switch up this 1/3, and I'm going to make the denominator in that one 6, meaning that I'm going to multiply this little guy. I'm going to change this exponent, this fraction, to 2 over 6. So we're going to rewrite this. 5 to the power of 2 over 6 over 4 to the power of 1/6. Okay, now I'm going to pull out the 1/6. So I'm going to say, hey, what do I have to the power of 1/6? All right, that's going to leave me with 54 squared, because you still need to keep your numerator on there. So because we only pulled out 1/6. So 54 squared over 4. And now when you go ahead, I'm assuming that you would use a calculator in that one, you get 54 squared divided by 4 actually gets you 729 to the power of 1/6. And using your calculator, you probably need to say, what's the 6th root of 729? Well, that's 3. All right, so that's kind of a calculator version. And again, I'm going to give you option 2 on this because there's a few different ways that we can solve this. So I'm going to start here with this cube root of 54 over 6 root of 4, because that's kind of where we left off. We're just combining it here. I know that 54 can be broken down into 2 times 27, and 27 is a perfect cube. So I'm going to say 27 times 2 over the 6th root of 4. And this one gets a little bit complicated, but stick with me. So we have 3 cube root of 2 over 6 root of 4. And once again, I'm going to switch these into these exponents. I'm going to keep the 3 out here. So I'm going to say 3 times, we're going to say 2 to the 1/3 over 4 to the 1/6. And once again, I'm going to write that exponent again on the top as 2 to the power of 2 over 6 over 4 to the 1/6. I'm going to pull out a 6th, and I think you'll start to see here that this actually reduces to 1. So 2 squared over 4 to the 1/6. Well, 2 squared is 4, so this entire thing right here is going to go ahead and that's going to reduce to 1. 1 to any power gives you 1. So this entire thing right here reduces to 1. 3 times 1, that's 3. So a little bit of a trickier way, but once again, you might be in a situation where you don't have a calculator and kind of have to play around with these numbers to see your answer on that one. All right. Example 5. Let's talk a little bit about our conjugates, because you'll definitely have some fractions here. 1 plus root 3. Okay, given this situation, this is what they're going to give you and say simplify. All right, now we're going to multiply by a version of 1, and that version of 1 is going to be 1 in root 3, 1 in root 3, and I'm getting that from this denominator right here. The difference on your sign is going to be opposite of your sign here. So this is going to be a negative, and because when we multiply these out, that middle term disappears, right? So this times this gets you a negative root 3. This times this gets you a positive root 3, which of course cancel out. So now you just have to multiply your first and last terms. All right, so 1 times 1 minus root 3, of course, is 1 minus root 3. This is going to be 1 minus 3. Okay, we can do that. So this is 1 minus root 3 over negative 2. I don't like to keep the negative in that denominator, so I'm going to multiply everything by the negative. So negative 1 plus root 3 over a positive 2 to make that denominator positive there. Pull that negative out. All right, let's take one more look at a conjugate. You guys are doing such good work. Example 6. So 2 over, now we're going to have double roots. I usually like double roots because they end up kind of disappearing here. So it's up to you how you want to solve this one. And again, this is now going to be minus root 7 over root 8 minus root 7. I'm going to keep that root 8 just as a root 8 right now so that my denominator becomes, so we have 2 root 8 minus 2 root 7. Please distribute your 2 to both terms here. And then this bottom one becomes 8 minus 7. So that's why I kept it there as a root 8, so that that denominator, 8 minus 7, of course, is 1. So the denominator is just 1. Making this 2 root 8, that's actually 4 root 2, because root 8 goes in, turns into 2 root 2, and you're going to multiply that by that 2, minus 2 root 7. And that's final answer on that one. Not a lot of work to put in. So we can start to see that they all turn around, they all get a little bit of a different form. All right, 2 more. So example 7. We're now working with some cube roots with a fraction, which we know we'll see. So let's take a peek at it now. All right, so we know, hey, can't have radicals, can't have fractions inside of radicals. Those are one of those rules. Let's break it up, see if that helps us out a little bit. So cube root of 7 over cube root of 4. Oh, can't take the cube root of 4, can't take the cube root of 7. So we're going to have to multiply this by something. So when we had radicals, we would just multiply it by whatever was in the radical, and that worked out because it was a square. But I want you to start thinking about this. Hey, what number do I need inside my cube root? So what number do I need right here in order to take a perfect cube? Well, I can multiply a 4 by 2, and that's going to get me 8. Now you have to kind of play around with factors right there, right? So I'm trying to get to cube root 8, because if I can get to the cube root 8, then I can go ahead, this right here can be simplified to a whole number of 2. In order to do that, switch to a light blue for this one, I need to multiply by cube root 2. Excuse me, I forgot the root on that first one. That's what I need to multiply by. So if you'll notice here, you're not always just multiplying by whatever's inside. Because if you did, you would get cube root 16, and cube root 16 doesn't help you out. We want cube root 8. So heads up on that one. So now we have cube root 14 over cube root 8. Well, absolutely we can take that cube root of 8 to make that denominator a nice integer number of 2. Can't do anything with cube root 14 though, so we got to leave it just like that. Last one for ya. Last one, example 8. I think I chose a doozy though, so let's go ahead and take a peek at it. All right, we have 5 times 24 to the power of 1/3 minus 4 to the power of, 3 to the power of 1/3. Okay, well, 24 and 3 are not the same base, so I can't just combine here. But we can go ahead, we can think about this in 2 different ways. FYI, my problem's given to me in exponent form. I need to return the answer in exponent form. But in the meantime, I noticed here that it's a little bit easier for me to work with radicals. You might see this in a different way, which I can show on option 2, but I'm going to change this into a radical, just a little easier for me to see, for cube root 3. Well, hey 24, you can be broken down into 8 times 3, and we like those factors because the cube root of 8, as we've said like 1,500 times today, is 2. So now we're looking at 10 cube root 3 minus 4 cube root 3. And some of the properties of radicals is that we know that if we have the same type of root, we can go ahead and just subtract those coefficients. So final answer here is 6 cube root 3, but I need to leave my answer in exponent form, so 6 times 3 to the power of 1/3, because I was given the problem in exponent form. All right, I do want to take a peek here at option 2. I'll write option 2 on the bottom. Option 2. So I'm going to start here. We have 5 times, I'm going to write 24, but I'm going to write it on the outside of those parentheses. It's the same thing. 3 to the power of 1/3. Okay, now I'm going to break up that 24. It's really similar steps to the other one, is that we have 8 times 3 power of 1/3 minus 4 times 3 to the power of 1/3. And as we can see here, this turns into 5 times 8 to the 1/3 times 3 to the 1/3 minus 4 times 3 to the 1/3. And this 8 to the 1/3 we know is 2. So it's really, really similar steps. The other one, 5 times 2 times 3 to the 1/3 minus 4 times 3 to the 1/3. 10 times 3 to the 1/3 minus 4 times 3 to the 1/3. I am going to factor this out though, so I'm going to write this as 10 minus 4, so I'm factoring out a 3 to the 1/3 times 3 to the 1/3, and 10 minus 4 of course is 6, times 3 to the 1/3, which is exactly what we got in the other one, just a different way of looking at it. All right, lovely example problems, excellent job. I will see you tomorrow.